Welcome back to All This Math. This is Professor Parker, and I got a couple books with me today. On this lesson, I got some books about, written by Marcus Garvey, the Honorable Marcus Mosiah Garvey, all right, founder of the UNIA, ACL, which is an acronym for the United Negro Improvement Association and African Communities League, all right. Now, why am I talking about Garvey? I'm trying to be intentional. There's a reason I'm talking about Garvey while I do this video is because we're doing a nursing school word problem. And one of the features of the UNIA was the Black Cross nurses, the Black Cross nurses. If you never heard of the Black Cross nurses and you never heard of the UNIA, I highly recommend you go do some research on both of those entities. The Black Cross nurses was a formation within the UNIA. All right, sisters that were trained as nurses, that were meant to provide healthcare to the Black community, in the early 20th century, right? Here's a couple of books about Marcus Garvey. Here we have Marcus Garvey and the Vision of Africa, edited by the late Dr. John Henrik Clarke, with the assistance of Amy Jacques Garvey, which was Garvey's second wife. His first wife was also named Amy Ashwood Garvey. All right, we have this is the classic, The Philosophy and Opinions of Marcus Garvey, or also known as Africa for the Africans. All right, so we got this. This is a banger. This is a banger. Definitely familiarize yourself with this. Then we got this text by Tony Martin. Tony Martin put together a lot of information and a lot of research about the Garvey movement, about UNIA and ACL. This is his text, Race First. Race First is the ideological and organizational struggles of Marcus Garvey and the Universal Negro Improvement Association. All right, so check that out. And last but not least, and these just a couple of joints I had in my own personal library, the selected writings and speeches of Marcus Garvey. So, Garvey was a very important individual. Like I said, if you never heard of Garvey, please familiarize yourself ASAP. If you have heard of Garvey, like a lot of us have heard of Garvey, but a lot of us haven't really read his actual words. Like, we've seen pictures and we've seen him on t-shirts and, he got some of his speeches are on YouTube. Like I've heard some of his speeches on YouTube. Of course, brother, passed away in 1940. So I was never able to hear his voice, but definitely check out, some information about Garvey, and it ties right into the math that we're about to do. Cause like I said, we're doing some nursing school math, right? Some healthcare math, and the UNIA had the Black Cross nurses. So that's a direct connection. So let's talk about this word problem. Now, as you can see, the word problem is not written on this board because I wanted to conserve space for the actual calculations and the actual math that we're going to do. But it can be found in the description underneath of this video, of course. So let me read it, because the first step in any word problem is to actually read the problem and understand the problem. So we first have the problem. It says that a nurse mixes 60 cc's, and cc is a unit which stands for cubic centimeters, right? Cubic centimeters, that represents volume, right? Volume of a liquid. 60 cc's of a 50% saline solution with a 10% saline solution, right? In order to produce a 25% saline solution. How much of the 10% saline solution should the nurse use? All right. Now, this is a typical, what we call quantity concentration word problem. Quantity and concentration word problem. So if you see a word problem like this, if you've never seen it before, it might seem confusing, it might seem complicated, but I'm going to show you basically the algorithm that you use whenever you see a problem like this. All right. Now, there's a formula we use that then enables us to set up an equation. So the way it works is like this. Now, in this particular situation, only two solutions are being mixed. All right. Only two solutions are being mixed to create another solution. Right. And you have to be very careful about the concentrations of saline because you want to end up with a certain concentration. So it matters. So the amount, right, of cc's of each solution matters, and also their concentration of saline. So saline is basically sodium. There are maybe other materials in the solution. Other people would be more qualified to speak more to the details of what saline solution actually is. But I'm gonna show you how to set up the equation in order to figure out answers to questions like this. So first, like the formula. Check this out. Quantity times concentration plus quantity times concentration is equal to quantity times concentration. That might seem kind of basic, and you might be thinking, well, how's that going to help me? You just wrote the same thing over and over again 3 times, right? Now, let's think about it. You start with this, right? And then you go back into the word problem, and you pull out the information that you need. So a nurse mixes 60 cc's. That's a quantity. That's how much. Quantity means how much, right? The volume, 60 cc's of a 50% saline solution. So first and foremost, our first solution is 60 cc's. And what's the concentration of saline? 50%. That means half of it has sodium in it, or half of it is saline. And then the other half is some other ingredients, right? So we're going to replace the word quantity with 60 cc's. So I do 60 cc's times, now it's 50%. So you got to know a little bit about percentages. You got to know how to convert percentages into non-percentages, right? Or a decimal in this case. So 50% is equivalent to 0.50. 50% is equivalent to 0.50. Now you can just memorize that, or mathematically what you do is you take the percentage and you divide by 100. That's the rule. You take the percentage and you divide by 100. Take the percentage and you divide by 100. So 50 divided by 100, like I said, is 0.50. Or you could just say 0.5, it don't really matter. All right, so now the next solution, it says the nurse is going to mix this with a 10% saline solution in order to produce a 25% saline solution. But notice how when you read the problem, and this is why reading is fundamental, right? We can't even really do math unless we have reading comprehension. We must know how to read and we must know how to comprehend. We can't just know how to recognize words and letters and syllables and all that. You got to really be able to read critically and understand what you're reading, understand what information is given, and also understand what information is not being given. So that way you'll know how to solve the problem. All right. So they didn't tell us what the quantity is in the second solution. They also didn't tell us what the quantity is in the resulting solution that you get when you mix this with this. They didn't tell us that, right? We know the concentration of this solution. We know the concentration that we want to end up with, right? I mean, think about this. This is like, it's like, I mean, it don't even got to be like in the healthcare context. Think about like making iced tea in the house, or mixing, some drinks or something, or some beverages or whatever, mixing something, right? This is the same concept, right? You got a certain concentration of sugar. You might need a certain concentration of a certain flavor, right? But if the more of it you have, then it's going to make it taste more like that. The less of it you have, it's going to make it taste less like that, right? But then you also got to look at how much of that particular ingredient is in that quantity that you put into it. So all of this, it's like a balancing act, right? But we could do the math in order to figure out exactly how much we need, right? So we don't got to guess. So we don't know this and we don't know this, but we're going to figure that out though, because we want to know ultimately how much of the 10% saline solution should you have, right? In order to get what you want. So we're going to call that X. That's our variable. That's our unknown. We're going to call that X. So this is going to be X times, I'm not going to use an X for multiplication because I'm using X for my variable. And that would be confusing. So I'm going to use the dot for multiplication, but then that looks weird because I already used the X over here, but it's all right. In the next step, I'm going to fix it. I'm going to make everything uniform. So then we got X times 10%, because I'm mixing this with a 10% solution, 10%, I'm going to change that to a non-percentage number, right? So I'm going to do 10 divided by 100, which is 0.10. 10% is just 0.10. So I got 0.10. And I could have wrote 0.1. I could have, right? But I like to write it like this, because just like I wrote it like that. All right, now, what is the quantity that I end up with? Now, if I got this much of this solution, and I got this much of this solution, or let's do this. Let's imagine that we knew how much of this solution we would have. Let's imagine that we knew that we was mixing it with 20 cc's of that. Then, in order to get the total, it would just be 60 plus 20, which would give us 80. So the quantity of the resulting mixture would be 80 cc's, right? But we don't know what this is. But that doesn't mean that we're not still just going to add them together. So even though we don't know what this is, we're still going to show addition. 60 plus X. 60 plus X. Now that's very important, right? That's one of those parts that confuses a lot of people. So I just broke it down for you and told you how you should look at it. 60 plus X. So the quantity that you're going to end up with is equivalent to 60 plus X, right? And actually what I'm going to do is this. Even though I already got parentheses here, I'm going to put another set of parentheses just around the 60 plus X, right? And then multiplication sign, I'm going to use a dot. And then the concentration, I want to end up with a 25% concentration, 25% saline, right? So because of that, now I got to convert that to a decimal, or a non-percentage. So 25 divided by 100 is 0.25. So this is going to be 0.25. So you see how we started out with this formula basically that you can use with every time you do a problem like this, every time you do a quantity concentration problem, right? You start off with this formula right here, and then you take the information from the word problem, make sure you read it carefully, read it thoroughly, and then you replace the information that you can with the numbers that you can, right? And if it's a value that you don't know, then you just replace it with a variable, like we did right here with this X right here. And also like we did here with this variable expression. This is called a variable expression. It's an expression that has a number and a variable in it. All right. So now we want to kind of clean this problem up. So first what I'm going to do is over here, I'm going to do 60 times 0.5, right? 60 times 0.50, right? Which is just 30, because 60 times 0.5 is 30, or half of 60 is 30. So this is going to become 30. And then we put the plus sign. And then I got x times 0.10. Now 0.10 is going to be my coefficient. The coefficient is the number that goes in front of the variable, right? That tells you how many of the variable you have. So how many x's do we have? We have 0.1 x's. We don't have a whole x. We have a fraction of an x. So we have 0.1 x. So what I'm going to do is this. I'm going to write it as 0.10x. I'll keep the 0. You don't need that 0, but you can keep it. And then over here, now we got to do distributive property, because we got a variable expression multiplied by a number. So whenever you see a quantity or a variable expression multiplied by a number, you got to distribute. So that means this 60 got to get distributed to the 0.25. The x got to get distributed to the 0.25. Meaning you got to multiply, because of that multiplication sign right there, you got to do 60 times 0.25, and then you got to do x times 0.25, right? Now, what's 60 times 0.25? 60 times 0.25 is basically 60 times a quarter, because that don't that look like 25 cents, right? That's a fourth of a dollar, all right? They're all the same thing. So 60 times 0.25 is going to be 15, because 1/4 of 60 is 15. If you throw it in your calculator, it's going to tell you the same thing, all right? So you got 15, and then you got 0.25 times x. So we got 0.25x. All I did was like just write the number in front of the variable, because this number is going to become our coefficient. All right, so we got 0.25x. Now this is our equation. All right, now in order to solve this, we got to know how to solve equations when you have variables on both sides of the equal sign. We got to know how to do that. All right, I have some other videos on the channel that show this specifically, how to do this. All right, now some people, when they see a problem like this, what they might do is try to get rid of the decimals by multiplying everything by 100. We could do that, but I mean, if you want to do that, that's cool. It's nothing. I don't got nothing against that. I just probably wouldn't do it. I mean, it makes the numbers bigger. It gets rid of the decimals, but it makes the numbers bigger. And I mean, it's cool. It's a matter of preference. You know what I'm saying? So, but anyway, if I got x's on both sides of the equation, and also keep in mind, there are multiple ways that we can solve this equation. There are multiple ways. Now, the way that I do it might not be the way you want to do it, and that's fine. That's fine. You got some freedom. You got freedom of expression when it comes to solving math equations. All right. But remember, our goal is just to solve for x. We want to know what value of x makes this a true statement. All right. So we'll know how much of the 10% solution that we need to combine with the 50% saline solution. All right, so let's do this. Let's get rid of this. We want to get x by itself, so let's do this. Let's get x on one side of the equation. So let's get rid of this 0.25x by doing subtraction. Subtract it to get rid of it because it's positive right here, so the opposite is subtracting it. But we got to stay balanced when we solve equations. So that means I also got to subtract 0.25x on the left side of the equation. I can't subtract it from 30 because 30 doesn't have an x in it, but I can subtract it from 0.10. So I do minus 0.25x. These cancel out, making 0. This is like 10 cents minus 25 cents. So we know that's going to give me a negative value because 10 cents is less than 25 cents. So that's going to give me negative 0.15x. Don't forget the x. Don't forget the x. A lot of students forget the x. Bring the equal sign down. Bring this 30 down. 30 minus 0.15x equals 15. Now I'm trying to get this negative 0.15x by itself. By itself where? On the left side of this equation. Over here. I'm trying to get it by itself. So what's got to go? This 30. This 30 got to go. So I'm going to get rid of the 30 by doing subtraction because this is a positive 30, right? So the opposite of a positive 30 is a negative 30. So that means I do subtraction. So I do minus 30 on the left. I got to stay balanced. So I got to also do minus 30 on the right. Subtract that. 30 minus 30 is 0. Bring this down. Negative 0.15x equals, what's 15 take away 30? Make sure you do your arithmetic correctly. That's going to give you negative 15, right? Now I'm trying to get rid of this negative 0.15 because I'm trying to get x by itself. So I do the opposite of this operation. This is multiplication. This means negative 0.15 times x. That's what that means. So I got to do the opposite of that in order to get rid of stuff. When we solving equations, whenever you're trying to get rid of something, you got to do the opposite of what's already going on, right? Just like, if it's cold out, you do the cold in your house, rather, you do the opposite. You turn the heat up, right? If it's too hot in your house, what you do? You turn the temperature down, right? You do the opposite to get what you want, right? You do the same thing with equations. So we divide by negative 0.15 on the left side, divide by negative 0.15 on the right side. You got to divide by the same exact number, Cancel that out because that equals 1. So now we got 1x. 1x is the same thing as just plain old x. So now I got x. And now negative 15 divided by negative 0.15. Let me make sure. That's 100. That's 100. Negative divided by negative is a positive. So that means 100 cc. So we think that we need 100 cc's of this 10% saline solution in order to end up with a 25% saline solution. All right. Now, we had 60 cc's that was 50%, but we need 100 cc's of a 10% to end up with a 25%. Now, that should make sense because notice how this is a 50% solution, but we want to end up with a 25% solution. So we need a certain amount of a 10% solution because that's significantly less than 50%. Right? But we still want to bring it up to 25% because it's all about balance. It's all about balance. And this the same thing you do without even realizing it when you're cooking and when you're mixing different things, different ingredients. It's the same thing. But we think this is the correct answer, but let's check our work. So that should mean that, let me see. So 60 times 0.50, as a matter of fact, let's check our work. Let's make sure that when we check our work, we make sure that the left side of the equation is the same as the right side of the equation based on this number. So 60 times 0.50 is 30. And then if we think this is 100 times 0.10 is 10. So we say 30 plus 10. That gives us 40. On the left side gives us 40. Now let's see if this gives us 40. 60 plus 100 is 160. 160 times 0.25 is also 40. So because we got 40 on the left and we got 40 on the right, using this value, that is proof that this is correct. It's proof this is correct. You always want to check your work to make sure that your answer is right. So therefore, you don't got to wait for nobody else to come tell you that it's right or nothing like that, right? You don't got to have that type of anxiety. Just go ahead and check your work, right? Now, if it didn't match up, then that means there's a mistake. Either there's a mistake in our original work or there could have been a mistake in how you checked it. That could happen too, but usually it's a mistake in your original work. All right. So you would go through step by step and try to find a mistake. That's the fun part, right? You're trying to find a mistake. All right. Now, if you don't find a mistake, then like I said, you might have made a mistake while you were checking it. You might have multiplied when you should have added. You might have subtracted when you might have divided when you should have multiplied, or something like that. You know, anything can happen. All right. So anyway, this is an example of nursing school word problems dealing with quantities and concentrations. Go get some practice on these, right? Watching this video is a good start. It's a reference, but it's not enough. You got to practice. Do a bunch of these problems over and over again until you memorize this, and until every time you see one of these type of problems, you'll immediately recognize the problem and then recognize how to do it. All right? So go get some practice. I'll see you in the next video. Peace.